You know when you see the ice in your drink melting on a hot day? Or when a puddle just disappears after it rains? It looks like magic, but it's actually one of the most incredible journeys in nature. Today, we're going to follow the amazing transformations of water.
Okay, so let's jump right in with a question that started this whole thing. It actually came from a chat between two friends, Avi and Thirov. They were sipping on some lemonade, looked at the ice cubes floating around, and started wondering, are ice and water really the same stuff?
So Thirov was totally convinced they were different. I mean, his argument was that ice is hard, right? You can hold it, but water just flows everywhere. Avi, though, he wasn't buying it. He pointed out that, hey, if you stick water in a freezer, it turns into ice. So, who do you think's got it right?
And the answer is, Avi was totally on the right track. Ice and water are, in fact, the exact same substance. They're just in different forms, or as scientists like to call them, different states. And honestly, this one simple idea is the key to understanding everything about water's journey.
So what are these different states anyway? Well, water has three main forms that we see all the time in our daily lives: solid, liquid, and gas. Let's break down what makes each one so unique.
Now this is where it gets really interesting, because this chart lays it all out so clearly. When water is a solid, like an ice cube, it holds its own shape, period. As a liquid, it's more flexible. It takes the shape of whatever you pour it into. And then as a gas, what we call water vapor, it has no shape at all. It just expands and spreads out to fill up whatever space it's in.
So what's the secret ingredient that makes all these changes happen? It's all about temperature. It's super simple. You add heat, and solid ice melts into liquid water. Add more heat, and that liquid turns into invisible water vapor. And if you do the opposite, take the heat away by cooling it down, the vapor turns back to water, and that water freezes right back into ice. It's a perfect two-way street.
Next up, let's look at how this all plays out in what feels like a magic trick, water's amazing vanishing act, which has a name: evaporation.
Seriously, have you ever stopped to think about this? You hang up soaking wet clothes, come back a few hours later, and they're perfectly dry. Or a big puddle on the sidewalk is there 1 minute and gone the next. Where in the world did all that water go?
Well, it didn't just disappear, it evaporated. Evaporation is just a fancy word for water changing from its liquid state into its gas state, that water vapor we were talking about. And get this process is happening constantly, all around us, even when it's not super hot out.
And you really do see this everywhere once you start looking. The floor drying after you mop it, sweat cooling you down as it vanishes from your skin, even that sizzle when a drop of water hits a hot pan. That's all evaporation, right there in action.
Okay, but here's where it gets really cool. No pun intended. When water evaporates, it doesn't just leave. It actually takes a little bit of heat with it, and that creates a cooling effect.
This is the secret behind why water stored in an old-school clay pot, sometimes called a matka, stays so wonderfully cool. A tiny bit of water seeps through the pot and evaporates off the surface, constantly cooling what's inside. It's the same idea as sprinkling water on a hot roof to cool down the whole house. Pretty neat, right?
All right, so water can turn into an invisible gas and just float away. But how does it come back? Well, that brings us to the other side of the story: condensation. I am sure every single one of us has seen this. You pour a nice, ice-cold drink, and just a few moments later, the outside of the glass is covered in little drops of water. Where did that come from? Did the glass leak?
Nope, it definitely didn't leak. That water came right out of the air around you. Condensation is basically the exact opposite of evaporation. It's what happens when all that invisible water vapor in the air touches a cold surface, cools down really fast, and turns back into liquid water.
So think about it. We've got evaporation sending water up into the sky, and we've got condensation bringing it back down. Now, when you imagine these two processes happening on a massive global scale, you get one of the most important things in nature: rain.
So let's walk through this real quick. As warm air full of moisture rises up, it gets colder and colder. That chill causes the water vapor to condense into teeny tiny liquid droplets. They usually cling to little specks of dust floating around up there. When billions and billions of these droplets get together, well, that's a cloud. And eventually, the droplets bump into each other, merge, and get so heavy that they just can't float anymore, and they fall back down as rain.
And this whole beautiful, non-stop process, water evaporating from oceans, lakes, and rivers, forming clouds through condensation, and then coming back down as rain. That whole thing has a name. It's the water cycle. It's the planet's circulation system, and it's what keeps everything alive.
And to really get how critical this cycle is, check out this piece of ancient wisdom from the Thirukkural. It basically says that without rain to fill it back up, even the huge, mighty ocean would eventually go dry. That is a powerful thought. Really makes you think, doesn't it?
So as we wrap this up, I want to leave you with this question. We've seen that water's journey is this perfect, continuous cycle. What do you think happens to our planet and to us if we start messing with that delicate cycle? It's definitely something worth thinking about.